So let me start by giving you this problem. There is a square plate, a uniform square plate. So there is a uniform square plate of side 2a. So the side length of this plate is 2a, and this plate is this A, B, C, D. So let me name it. There is A, then you've got B, then you've got C, and then you've got D. So ABCD is that uniform square plate, and it has got a side of 2a, and out of this plate we cut off a certain portion. So maybe we will cut this shaded portion. So from this plate the shaded portion has been cut off. The shaded portion has been cut off. Find out the center of mass of the remaining portion. And in order to find out the center of mass, okay, how will you represent it? Maybe you can figure out the distance of the new center of mass of the remaining portion from the center of the old plate. So this point is O here. You can take O as the origin, and you can give me the coordinates of the center of mass of the remaining portion, or you can give me the distance of the center of mass of the remaining portion from this point O, but it has to be with respect to O. Give it a try. Take 2 minutes. Yeah. So one way to do this problem is to assume that there are 3 separate small plates. There is plate number 1 here, top left, then you have got plate number 2, top right, and you've got plate number 3, which is bottom right, and the 4th plate is off, it's not there. And each of these plates will have the same mass because it's a uniform big square plate. So that means if I take this bigger portion, it will have the same mass as this big a portion, and it will have the same mass as this bigger portion. So perhaps I can take the mass of each of these pieces as m, and the center of mass of each one of them. So I can replace this plate number 1, let me shade it here like this. Yes, so I can replace plate number 1 with a small mass placed at its own center of mass, and the coordinates of this center of mass here are going to be minus a by 2. So they are going to be minus a by 2 and a by 2. Then you will have this second plate, which I can assume as a small particle placed at its own center of mass, and the center of mass of this plate is going to be at its own center. So this is a by 2 comma a by 2, and for the lower one I can think of that as a third plate, the blue one, and I can replace this blue plate with a small mass placed at its own center of mass, and the center of mass is going to be a by 2 comma minus a by 2, where for all the plates the masses are equal, m, m, and m. So now we have to find out the center of mass of a 3 particle system, and that is a very easy and standard thing to do. So x center of mass will be m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So this is a by 6, and y center of mass will be m1 y1 plus m2 y2 plus m3 y3 and divided by m1 plus m2 plus m3. So this is going to be 3m, and that is going to be a by 6. Now all the coordinates here are expressed with respect to this point O, and so the final center of mass coordinates are also with respect to O, and because we have got both of them as plus and plus, we know that the center of mass will lie somewhere here in the inside the second plate here. And further, because we have got the x center of mass equal to the y center of mass, we know that it will lie on the diagonal also, which is not surprising because we know that if there is an axis of symmetry, now even in the reduced figure, there's this 3 square figure which I had got, there was one axis of symmetry, and the axis of symmetry was this particular line. So this line was the axis of symmetry. So no surprise that the center of mass lies on the axis of symmetry, and it's somewhere there, this point. So this is how you can solve this particular problem. But then, having solved this, let me give you a different problem to negotiate. So another example can be this. You have got a circular plate. So this orange shaded part here is removed. This is gone, no longer there. And it has got a radius r, while the bigger one, the bigger plate, has got a radius 2r. And they want you to find out the center of mass of the remaining portion. So the question is to find out the center of mass of the remaining portion, and perhaps you can give me the coordinates of the new center of mass with respect to the center of the larger plate. So let me call that point some C. Can you do that? Try this out. So of course, I think you people have been able to figure out that you cannot do this problem using the previous method, because here you don't have any idea about where the center of mass of this red shaded part is. We have no clue where the center of mass of that part is. In fact, for that matter, we still have no clue where the center of mass of a half a disk, which is the blue shaded part here, that will lie. So since we have got no clue about the individual center of masses of these shapes, we cannot use these shapes to figure out the center of mass of the remaining portion. So there has to be something else. And what we do is this. So before we solve this, let me show you how that formula is derived. So let's say there is a figure. Let's say there is an arbitrary shaped figure. So center of mass of remaining figures. Let us say that there is an arbitrary shaped object. So you've got an arbitrary shaped object whose mass is known. Let us say the mass of this object is m total. And let us also say that its center of mass is known. Its center of mass is somewhere. So it's some point here, which is its x center of mass comma y center of mass. And from this big object, a small piece has been cut. That small piece which is cut is this small piece, and the small piece's mass is also known. The small piece's mass is m cut, and the location of the center of mass of the small piece is also known. Let us say that's this particular point here, and this is x cut comma y cut. So I can call this point as x cut comma y cut, and I need to figure out where is the center of mass of the remaining portion. Now the remaining portion is going to be a dark violet shaded part like this. and this remaining portion has got a total mass which is m remaining, which is going to be m total minus m cut. So the shaded portion here has got a mass which is m remaining, and this is m total minus m cut, and let the center of mass of this remaining part be somewhere. Let it be some point here. This is x remaining and y remaining, and this is the center of mass of the remaining portion. Now what I can do is I can solve the inverse problem. So let me say that there is one body which is the remaining body whose center of mass is somewhere here. This is the center of mass of this entire portion, which is remaining after this central part was cut. So let me take that. Let me also color it the same. Yeah. So one of the portions is this remaining portion whose center of mass is known, whose mass is m remaining. So I can replace this entire portion by a small mass placed at this particular location. And the second part is this part. The second portion is this portion which was in fact cut from here, and that cut portion's center of mass is that red point here. And when I try to find out the center of mass of these two objects, the red part as well as the dark violet part, I'm going to get the center of mass of the combined object, which is going to be at this point x center of mass, y center of mass, which is this green location somewhere here. So now what I've done is I've reduced this entire problem from a cut body problem to a completing the total object problem. So where I take the remaining portion and I take the cut portion, I put them together and I say that the center of mass should be at the original place. So now I know the formula for this center of mass. Now what I can say is that x center of mass should be it should be m remaining, x remaining plus, for this part, for the red part, I can say this is m cut and x cut. So you are going to have m cut, x cut divided by, you will have m remaining plus m cut. And when you get this entire equation, you can now rearrange this to find out what is x remaining, and that's a very simple thing then. So I just cross multiply and I try to solve. So what I'm going to get is m remaining into x center of mass plus m cut into x center of mass or what I can say instead of that is, if I add up m remaining and m cut, I'm going to get m total. M total is m remaining plus m cut. So I will do that here. I will write this entire term as m total in one step. So this is m total and this is x center of mass, which is the center of mass of the total portion. So x total is equal to, and I'm going to get this m remaining, x remaining plus m remaining, x remaining plus m cut, x cut. And a simple rearrangement will show you that x remaining will be m total, x total minus m cut, x cut by m remaining. and I can rewrite this m remaining as m total minus m cut. So you are going to get m total x total minus m cut x cut divided by m total minus m cut, and this is all equal to x remaining. This is the x coordinate of the center of mass of the remaining portion. And in the same manner we can also find out the formula for y remaining, and since it's analogous we don't have to do it again. I'm just going to rewrite it. So we are going to get y remaining is equal to m total x total minus m cut x cut, sorry, now it will be y total and y cut, people, so my bad, y total y cut, and you will have m total minus m cut in the denominator. So that is how the formula works, and now I think you will be easily able to get the answer to this this disk cut out from a bigger disk problem. So let's try to solve this particular problem and remove these unnecessary parts. Let us say that the remaining portion has got the center of mass somewhere on the x-axis, here, this place. This is the center of mass of the remaining portion, so it will have just x remain comma 0 coordinates. The y coordinate will be 0. The center of mass of the cut portion is at the center of this orange shaded portion, so this point, and the coordinates of this point are going to be minus r comma 0. And how much is the mass of the cut portion? The mass of cut portion is going to be pi r square times sigma, where sigma is the surface mass density. So this is mass per unit area for this entire plate, and because the plate is uniform I can use this variable here. So mass per unit area multiplied by the desired area will give me the desired mass. So this is the mass of this orange shaded portion, and the mass of the remaining portion is m remaining is pi into 2r whole square minus pi r square, because that's the remaining area, times sigma, which is equal to 3 pi r square sigma. So if I take this as small m, I will take this guy as 3 small m, and the total mass then becomes, so therefore m total will become 4m. And then according to the formula x remaining will be, so therefore x remaining will be m total x total. Now for these two parts, if I take the remaining part and this small part, the combined center of mass is going to be at C, which is the origin, so 0. So m total x total minus m cut x cut divided by m total minus m cut, which is going to give you r by 3. And so you have found out the answer to this particular problem. And the same thing could have been done even for the square problem, which I will leave to you as an exercise, and we will move on to maybe finding out the center of mass of some other shaped objects.